But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. Hi, welcome to part 2, the evidence. If you haven't watched the first video, you really should, because much of what follows will not mean a lot to you unless you understand the source and the reasons for what follows here. So please go back and watch that video. If you are returning, welcome back. Here, as promised, is the evidence for the assertions made in video 1 and the proof that those assertions are correct. Just a little background before we continue. Much of what follows is taken from a document I wrote around about April, May last year, 2020. And I just got to the stage where I'd spent so much time on this video that I, rather than represent it all in a nice glossy fashion, I've taken a lot of screenshots of that documentation. So the quality isn't the best, and I apologise for that, but I think the message is fairly clear and should get through and convince you. So let's just start looking at the 16 fairly major bugs that I found while researching this. As you can see there, I've classified them into like 4 major causes, and if you have seen video 1, you'll understand what each of those means and why and how they relate. So for that first one, just reading the GitHub issues page is the proof you need for that. There's dozens and dozens of people complaining about spontaneous disconnection and reconnection loops. I use the abbreviation DCX-CNX, that's just my shorthand. But here is a classic example of the dangling pointer problem. What's happening here is that each of the messages being sent has come back into the danger zone with a corrupt pointer, and the data that's received by the server is junk, and the MQTT 311 protocol requires that in that scenario the server must close the connection. It's a must do, and so the server closes the connection. Obviously there's a disconnect message. The code is designed to reconnect immediately, and so it does. And if the persisting conditions that caused it in the first place are still there on the reconnect, because it's not a reboot, mind you, so if the state of the memory of the calling program is such that it's caused the corruption next time, then quite often this just goes into a disconnect, reconnect, disconnect, reconnect, disconnect, reconnect loop until the memory juggles itself into a position where it happily and accidentally comes back into the green zone. So number 1, you understand how that works, and number 2, the evidence for it is there's too much of it. Before we go through the rest of them, I will say that there actually were a large number more, but being random and undefined, they were difficult to reproduce. I'd spot the error and think, oh good, add that one to the list, but I'd run it again, it wouldn't happen again. Such is the nature of undefined behaviour. And also, just from a mental health point of view, there comes a point at which flogging a dead horse becomes gratuitous and pointless. You know, this library is dead in the water already. It's unusable. It totally fails to match up to what it claims to be able to do. You know, and by the time I'd got to 16, I thought I'd fairly well proved the point, and so I didn't bother anymore. However, moving on, let's go and look at the wheel topic. This is a bug which causes, again, another disconnect reconnect loop, because it's another example of the dangling pointer with a unique property that this always, 100% of the time, always ends up in the danger zone, causes, for the same reasons as the previous, a closed connection by the server with then an automatic reconnect by the library code. And if you pass in a temporary or stack variable, which is going to go out of scope at the end of the set wheel function, 100% of the time it will fail. So you cannot use that call in that context. You can only use statically allocated variable. Just a little random one here. Some topics are unacceptable to MQTT. It rejects them. Rule 1 applies. It closes the connection. I might be lying about that. I think it might just give back an error code. However, the point is that the library doesn't check the return error codes for that. It appears not to know that it's possible to get an error back, and there's no callback mechanism for the user to handle it anyway, so it just carries on as it is, and you subscribe to a topic and you never get any messages for it, and you're never told why. So you think it's your code that's the problem, when in fact it's the library being very badly written that's the problem. Discarded messages number 1. Little bit of background. By the time I got to writing this document, I knew where pretty much all of the bugs in the library were. Not specifically all of them, because as we know, one particular one of them causes any number of random problems. However, I knew what conditions to create to cause the bugs to occur. And in order to generate the evidence, I wrote a program which was remotely controllable via MQTT, which would vary the size of the packets that it sent, the number that it sent, and the rate and the QoS level, etc. So I could just basically key in the parameters for the next thing I knew that would break it and print the results. And here's one, for example. I think this is the overlap problem, whereby a combination of the number and size of messages sent gets to the point where the buffer can't get cleared quickly enough, and all things start going wrong. So messages start getting discarded because the ACK cycle doesn't work. So this particular example of the BS factor, carefully chosen, I sent 10 consecutive messages of 100 bytes. Now that really isn't a lot. I mean, this isn't stressing it. This is only just one footstep off of the happy path, and only 9 of them get sent. 10th is discarded silently. The code continues regardless. There's no mechanism for informing the user that one of his messages didn't get through. And that's fine, as long as you're not sending messages that contain data that are useful and mean something. If you are, it's potluck whether they get through or not. Discarded message number 2. I'm not sure what's happening here, to be precise. Well, I am, but if you look on the left, you can see there's kind of 2 copies of the green text, because I'm running Pangolin and this lib side by side. It's only the results of one being shown there, and it appears to show. Oh yeah. No, what it's showing is that with 4 consecutive messages of 500 bytes each, only 2 get sent. So in the previous one we sent 10, 9 got through. This time we sent 4, 2 get through. And one of the problems with trying to debug your own code with a library like this supporting you is you get these different results all the time, which make it very, very difficult to try and spot what's wrong. And the reason it's difficult is because it's not your code. It's the library that's wrong. And so moving on, we have a total message loss now. We send 2 consecutive messages of 1500 bytes each, and neither of them get through. No data is sent whatsoever. No messages get through. You're not told. Your information is just thrown away. Call me old-fashioned, but I'd say that's not very useful. Killer packet. This is to test the fragmentation on inbound large messages. So I sent a 50k. I published a 50k topic to a topic that I knew was being received by the library, and nothing happened. Nothing happened at all. So to be honest with you, I thought it was going to crash. I thought it was. I mean, I knew that it was going to not be able to reassemble the packet. We've covered that in detail in Volume 1. I'm just trying to generate the proof of that now for the evidence phase. I fully expected it to crash, but actually nothing happened at all. So I thought, well, I'll stop my process running by remote control, and then I'll get on with the next test then, because that one wasn't very helpful. And then out of the blue, 30-40 seconds later, it just suddenly went into a loop, splurging out hundreds and hundreds and hundreds and hundreds of messages saying that it had received a stop message. I don't know where that's come from. I think it's broken that 50k up into smaller messages, and because it doesn't know properly how to do a refragment, it thinks that each one of them is an incoming message. It's confused it with the other message. I don't know what happened, but then just as quickly as it started, about a minute later it stopped. Totally bizarre. Right, on to QoS protocol violation. QoS 1 rules, according to the specs, say that the client must follow these rules when implementing the protocol flows. It must, when it resends any published packets, well, I'm going to stop there, because the biggest problem we have here is there is no code in the library which ever attempts to resend any packets. Proving just by code inspection that it absolutely cannot fulfill any function of QoS 1. It's that simple. So any claims on the front page that you can publish at QoS 1 are complete nonsense, totally untrue. There is no code to properly recover a resend, which is what QoS 1 is. Here's the proof, is that you're required on a failure, as per that spec, to send the acknowledgements which constitute the QoS 1 messages in the same order that the messages were sent. Well, here is 69, 70, 71 and 72. 72 just went off the screen, being sent, and then they are received back in the order of 69, 71, 70, 72. So the library completely breaks that protocol, yet still claims to be protocol compliant, which begs the question of how well it was tested, with the obvious implied answer, well, not very well at all. Fragment failure. This is going to get bizarre, but if you've watched video 1, you'll understand how it happens if you think hard enough about it. So what we've seen previously is messages being discarded and lost. What you're going to see here is messages being created out of thin air and injected into the stream where none existed. And I paused there to let you think, did I just hear what I thought I heard? Yes, you did. So I sent 8 messages of 100 bytes each. Now let's pause there. 100 bytes is below the limit of 128 bytes. That is already a very low limit in a library called, for example, pub/sub/client, one of the most popular libraries, which only operates at QoS 0. But then again, so does this library. However, 100 bytes is not a big message, and 8 messages in a row isn't a lot of messages. The total of 800 bytes isn't a mass amount of data. It is, however, bigger than the LWIP buffer that was compiled in at the time, which is why I chose that value. Now, because of the failure to fragment packages, what's happening is that when TCP packs these packets into that buffer, which is then full, it has to get sent, depending on the size of the buffer and the number of them, it depends on the number that go in. Now, when those acknowledgements and messages come back, etc., etc., the unpacking process goes the same way. So you might get 2 parts of a packet in one, and you can even get a single message split between 2 packets. So unless you reassemble it properly, you get half of a message in one packet and the second half of it in the beginning of the next packet. Now, on a correct reassembly, that all gets stitched together. It's not an issue. But if you do it wrongly, you get extra fragments in there that you think are messages that actually aren't, and they're part of messages. So I send out 8 and I get back 9. On the second test, I got back 10. It's pot luck. So it's manufactured messages that never existed because it can't properly manage the refragmentation, which is as about a bad a bug as you can find in any library, and in a situation which is barely one step off of the happy path. Another protocol violation, 2 for the price of 1 on this. Client 4.4, client reconnects with the clean session set to 0. Both the client and the server must resend any unacknowledged published packets. Well, in order for it to do that, it has to save them somewhere, doesn't it? There is no code anywhere in the library where it ever saves any message so that it can resend it, and there is no code in there that ever performs any resending. So how the author has the nerve to claim that QoS 1 and QoS 2 work when, even if you hadn't seen video 1, just looking through the code, you'd see that there is no code in there to fulfill that section 4.4. It just does not work. It's that simple. Similarly, with session recovery, which is a fundamental part of both QoS 1 and 2, there is no code in there in any way, shape or form that does anything with managing sessions. And there's the proof. There's the code that occurs on a connect acknowledge to say, okay, you've got a good connect. Here is the state of the current session. And all this does is pass that session to the user, that session present message. As you can see with your own eyes, there is nothing in there that could possibly initiate a resend of any messages, especially when you know that none have been saved. And this is why I keep using the phrase total failure. That's not me being a bit kind of, rub it in. It's not to say it doesn't work very well, it just doesn't work at all. Furthermore, what can the user do with that session marker? He knows nothing about sessions. It's nothing to do with him. That's the library's responsibility. And like the packet reassembly, here we are with the author apparently not understanding really what it's about, passing it back to the user in the hope that they do. I can come to no other conclusion. So 2 for the price of 1 on that page. There's no session recovery, therefore MQTT rule 3126 says if the clean session is set to 1, the client server must. It doesn't matter what it says after that, because you know that it does nothing to perform any differently on that session present marker. So it can't fulfill whatever's in the rest of that statement that I didn't even bother reading. Right, QoS 1 says this: if you publish a message, I guarantee that I will acknowledge when it's been delivered. And that holds true even if the connection breaks, and especially when the connection breaks, because that's really only when the QoS things matter. So what I was doing here was running Pangolin side by side with MQTT-lib. And first is Pangolin, which has just recovered from a reconnection that it deliberately inserts into its process in order to generate a QoS failure so that it can then recover from it. So this program, it's not doing anything useful apart from providing proof both that Pangolin correctly recovers QoS 1 and that asyncMqttClient absolutely doesn't. And here's the proof. So just walking through that, it opens up with saying, I've got a dirty session, because it's obeying the 2 rules we've just seen previously. I've got a dirty session. That means that there's been a failure and that there is some session state that's going to be recovered. Now, if you look at the original code, it opens up by doing a publish and then a receive. Publish, receive, publish, receive. And it publishes those pairs, and at 5% of the time, it deliberately breaks the connection in between the two so that the send never gets, the receive never gets received. In which case, the compliant server says, this person didn't acknowledge receiving that, I'll have to send it again. That's what QoS 1 means. So here we see, let me get a big cursor up here so you can see what I'm doing. here you see that Pangolin code diagnostics have recognized that that's the case because it's got an inbound message before it's even sent anything, and that message is the QoS1 recovery message, so it knows that QoS recovery is in action. It doesn't know, technically doesn't know how many resends it's going to get, it just knows there's some, and so it started. So it's receiving 236. Now bearing in mind it's just made a connection, where's that 236 come from? Well, that's the sequence number of all the transactions that the server has been maintaining, and that was the last one that was sent outbound in the previous session that crashed. So the server is saying, you sent me 236 a while back and it didn't get acknowledged, so here it is again. And it receives a 236, says that it's got the duplicate value received, and then it passes it back to the user, who can either do what he wants with it if he didn't get the last one, or if he did get the last one, just not the acknowledgement, he can ignore it if he chooses. That's the rules of QoS1. You can get multiple duplicates for the same ID. That's allowed. It just says it's guaranteed to be delivered at least once. And then it continues. Now this is the whole point of a session, so this is just reconnected, but the serial numbers continue from where they left off on the previous session. That's what a session means, a dirty session. Its own IDs start at 1 because it's just reconnected, so it's sending out a message which is going to be 237 to the server and 1 to me. And then just a summary statistics with a kind of sanity check which says that since I started I've had 10 reconnects, all forced by this deliberate 5% of the time business. Of those 10 reconnects, I got 10 duplicate messages. That means the server is honouring its side of the bargain. And I have this number of incomplete send receive pairs, 0. If that number is not 0, it means I've missed one of those records. So this is the sanity check that says whatever that's 0, that is stone cold proof that QoS1 is working. Now let's look at the other nib. Boom, 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 boom. 10 reconnects, the same as mine because they're running parallel. So I started them both identically at the same time, and they've both got the same. Here's the thing: they're both running exactly the same code. Okay. So there's the 10 reconnects. There's the server honouring its side of the bargain, and here, which you'd absolutely expect if the previous slide were true, is 10 failures to receive and handle the duplicate message of the QoS1 recovery. Even though you've got to dig through the figures to find it, that there is the proof that it does not operate QoS1 at all, because it's been sent 10 recovery messages and it's ignored all 10 of them. Starting to get a little bit repetitive here, but here's the same thing happening on a QoS2 breach, which is no surprise. We're getting to the stage, we're getting to the dead horse stage now, where it's, yeah, okay, yeah, we know it's not going to work. There's your proof for the record, if you like. So let's move on to the bizarre, illogical, dysfunctional and incorrect. Now some people might think those words are a bit strong or emotive or whatever. You can be the judge of that when we get to the bottom of this section. First of all, there's no error handling callback, and there's no way for the library to warn the user of some errors, and some errors are just totally ignored at all. So even if there was a mechanism, you wouldn't get told about them. That's dysfunctional. It's functionality that needs to be there but isn't, which is the definition of dysfunctional. On message, there's no reason why QoS, dupe and retain flags should be inside a structure in the callback function. Absolutely none at all. I just cannot think why. It's the only structure used in the whole program. There's no kind of pattern or style or anything. Just that's got 3 flags in a 3-bit flags in a structure. Why? And why has it got a name that's 33 characters long? I mean, to me, that's bizarre. It may not be to you, but I won't reiterate the reassembly point and problem. I'll move on to MQTT We've seen already from a couple of slides back that passing the session flag is redundant. So that's illogical. It's also it's incorrect because there's nothing the user can do with it, and you should have dealt with it yourself. Now we get into the realms of Kafka-esque rather than these others. On publish, on subscribe, and on unsubscribe, callbacks aren't callbacks that occur asynchronously after those things are finished to tell you that they successfully completed. After all, you've got QoS for that. These call back after you publish. So your code will go publish this topic, and then you'll get called back to say you just called publish topic, and here is a session ID which you can't do anything with because you don't know what it's about and you don't know what it means. Why? I know I've just called publish. Look, it's that line in my code. There it is. Why are you calling me back to tell me that I've just called you? Save as on subscribe. You choose when your code does that. You subscribe when you want to subscribe, and as soon as you've done so, it'll call the unsubscribe callback and say, hey, you just subscribed. You go, no, I did. I just called subscribe. It's about the most illogical thing I've ever seen in a library. Totally and utterly without merit or use or function. So again, it's bizarre. That's the corker, because it's all of them. It's bizarre, illogical, dysfunctional, and it's incorrect because it's just not something that anybody that knew how this library worked would ever dream of putting in. And so the three functions that set those values are also redundant and pointless. Packet IDs. This is getting beyond Kafka-esque. This is into the realms of what on earth was the author of this library thinking, because anybody that understands how this works would know that this is absolute and utter nonsense. The packet IDs are the IDs that we talked about before. They're internal values generated by the two sides of the conversation to synchronize the protocol for QoS 1 and 2 recovery. They are known only unto the server on the far side and whatever sends the packets on this side. Or you could argue, yeah, well, that's your user code indirectly, isn't it? Yes, but it has to have the other side of the conversation for this side of it to mean anything. And I'm not going to go into the full details of it, but the point is there is absolutely no circumstance ever under which the user should even see a packet ID, let alone have one handed back to him as the return code of an imperative action. It's just, it beggars belief, and is part of the reason why in video 1 I say I just think that the author of this library just did not understand how the protocol works. Publish, got the wrong data type. It's treated as a char when it isn't a char, it's a uint8. And if you think they're the same thing, well, A, you're wrong, and B, it's no surprise that things like this get written then. It's not a char, it's a uint8t. It is not, as a payload in its own right, a C-style string, which unfortunately a lot of the code tends to imply that it thinks it is a string, which again convinces me that the author perhaps doesn't even really understand how C works, because it's 8 bits. It's an 8-bit byte. It can contain any data at all, including a 0 is a perfectly valid payload character. I can send a perfectly valid payload of 100 zeros, nulls, which is not a C string. Kind of by definition, null is what terminates a C string. So if you treat a payload as if it were a string, your code is going to crash most of the time because you're expecting it to have a null at the end. There's absolutely no guarantee that it will have. And so you'll run off the end of the buffer. So point is, demonstrates that whoever chose that doesn't understand how payloads work. But the bigger problem is the presence of the dupe flag, and to explain that I'm going to jump again to the spec, which says that the dupe flag is in the outgoing published packet is set independently to the incoming published packet, and its value must be determined solely by whether the outgoing published packet is a retransmission. Now, how does the user know that a retransmission has occurred? How does the user know that a disconnect and reconnect occurred in a dirty session when the library A doesn't hold those, and B, it's not the user's job to do that, it's the library's job to do it, and it fails to do it entirely? And so again, there is never any circumstance in which a user should be able to set the dupe flag, because that is him telling the library and the server that this is a duplicate message based on information he cannot possibly have access to, because he's not controlling the conversation. The library's controlling the conversation. Again, this is an instance where the library looks like it doesn't know what it's doing, so it just passes it back to the user in the hope that he does. This alone, if I was like a forensic analyst, this alone would tell me that whoever wrote it doesn't understand MQTT protocol. Getting very close to the end now. Setwheel's got a couple of bugs in it. It's got that same incorrect data type in it because it's also a payload. It's kind of trivial, but it just all adds to the picture of absolute unfitness for purpose of the library. And on disconnect, again, just shows a kind of cavalier attitude and an apparent lack of understanding about data types and C, because both LWIP and ESP async TCP produce negative error messages in some occasions and positive in others, and they kind of use that to distinguish between the two different groups of messages. So if you've got a uint8t, it means you don't understand that, because otherwise it would be an int-t, wouldn't it? Because it's a signed value and you've given it an unsigned data type. Now you can go through some hoops and muck it around and go blah blah blah. It's not fatal, it's just again another indication that whoever wrote it just really doesn't understand what's going on under the hood. And in video 1 we've seen that what's going under the hood is very, very bad indeed. It kind of brings me to the end of this this very long 2 series videos, and the summary is really, well, there's nothing more I can say. You've seen how bad the library is, you've seen how it gets that way. You've seen the proof of what happens because it's that way, and well, you draw your own conclusions. At least you now know the facts, and you can make a decision about whether you would ever want to use that library or not. So thank you for taking the time to sit through all of this. I know it's been extremely long, but I think it's important to understand 2 things. One, that I don't generally say things that I can't back up with proof, and 2, that this library is not fit for purpose, does not do what it claims to do, and really is a pretty shabby affair. As always, thanks for watching. Please remember to subscribe, like, click the notification button, and support me on Patreon if you can. Thanks, and see you next time.